There's something wrong with your soil right now that you have probably blamed on everything except the actual cause. You have added fertilizer, adjusted watering, amended with compost, tested the pH, and watched the same plant struggle in the same spot season after season. The problem is not your technique. In many cases, the problem is growing right next to the plants you are trying to save, and it has been there the entire time. Allelopathy is the word botanists use for it. Certain plants release chemical compounds into the surrounding soil through their roots, decomposing leaves and bark that inhibit, suppress, or outright kill neighboring plants. It is not accidental. It is a competitive strategy refined over millions of years to chemically degrade the growing conditions of everything nearby. The garden center is not going to put a warning label on these plants. Most are sold as desirable ornamentals, productive food crops, or useful ground covers. None of them come with instructions explaining what they are doing to your soil. That is what this video is for. Plant 1. Black walnut. If one plant has caused more unexplained garden failures across North America than any other, it is the black walnut, and most people never identify it as the source because the damage radius extends far beyond the canopy and sometimes far beyond the property line. Juglans nigra is native to eastern North America, a magnificent tree reaching 18 to 30 meters, with deeply furrowed bark and one of the most valuable hardwoods on the continent. The nuts have been a food source for thousands of years. The wood has been prized for centuries, and the soil within its reach is chemically hostile to a significant percentage of garden plants. The compound responsible is juglone, a naphthoquinone produced in the roots, bark, leaves, and hulls, and released continuously into the surrounding soil. Juglone interferes with cellular respiration in sensitive plants, blocking their ability to use oxygen effectively. The result looks like wilting, yellowing, and slow decline, progressing to death over days to months, depending on concentration and plant sensitivity. The damage zone extends roughly 15 to 18 meters from the trunk, driven by root spread rather than canopy spread. Roots from a large black walnut have been documented extending 25 meters from the trunk, meaning a single tree can cover the equivalent of a large suburban backyard entirely. Tomatoes wilt and die within days of meaningful juglone exposure. Peppers, eggplant, potatoes, apples, pears, blueberries, azaleas, and rhododendrons are all highly sensitive. After a black walnut is removed, juglone persists in decomposing roots for 5 to 8 years. Gardeners who remove the tree and immediately replant watch their new plants fail for exactly the same reason as the old ones and conclude that something else is wrong with the soil. Juglone-tolerant plants include most grasses, native wildflowers, beans, beets, corn, squash, carrots, and certain fruit trees including cherries and plums. For removed trees, wait a minimum of 5 years, amend heavily with compost, and test with expendable annuals before committing expensive perennials to the space. Plant 2. Garlic mustard. Garlic mustard does not just suppress neighboring plants directly. It dismantles the underground fungal infrastructure those plants depend on to survive, which makes its damage far more systemic and far harder to reverse than most allelopathic plants on this list. Alliaria petiolata is native to Europe and Western Asia, introduced to North America in the mid-19th century as a culinary herb. It now grows across the eastern United States and into the Pacific Northwest, favoring the woodland edges and forest understories that also support native wildflowers, tree seedlings, and the mycorrhizal networks connecting them. The allelopathic compounds in garlic mustard's roots are antifungal glucosinolates that break down into compounds toxic to mycorrhizal fungi. These fungi form symbiotic associations with plant roots, providing access to phosphorus, nitrogen, and water that roots cannot reach independently. When garlic mustard destroys the fungi, it severs the nutritional infrastructure native plants depend on, causing decline not through direct toxicity, but through starvation. Research documents garlic mustard reducing mycorrhizal fungal diversity in affected soil by between 30 and 90%. Native tree seedlings, including sugar maples, red maples, and oaks, show significantly reduced growth and survival in invaded areas. Native wildflowers, including trillium, trout lily, bloodroot, and wild ginger, decline measurably within years of an established invasion. Each plant produces between 400 and 900 seeds, viable in the soil for up to 5 years. A single plant becomes a dense colony within 2 to 3 seasons. Pull the entire root before seed set in spring, bag all material rather than composting it, and return for 3 to 5 consecutive years to address the existing soil seed bank. In heavily invaded areas, reintroduce mycorrhizal fungi through commercial inoculants applied to the roots of new plantings to help rebuild the soil biology the invasion degraded. Plant 3, eucalyptus. Eucalyptus was introduced to California in the 1850s with commercial optimism that did not survive contact with what the tree actually does to soil. Promoters saw fast growth and timber potential. What followed was the chemical reconstruction of the soil beneath those trees into a state inhospitable to most other plant species. Multiple eucalyptus species now cover an estimated 40,000 acres across California, with Eucalyptus globulus, the blue gum, the most widely planted and most ecologically disruptive. The allelopathic mechanism is multi-layered. Volatile oils, including cineol and terpene compounds, are released from leaves continuously and deposited on the soil when leaves fall and accumulate as deep litter. Those compounds inhibit seed germination broadly. The roots release water-soluble phenolics directly into the soil. The leaf litter decomposes slowly due to its high terpene content, creating an acidic, chemically active mulch that suppresses the soil microbiome necessary for nutrient cycling, and the root system extracts water and nutrients aggressively, compounding chemical suppression with competitive exclusion. The result in established eucalyptus groves is near monoculture understory. Virtually nothing native establishes successfully beneath mature blue gums. For home gardeners in California, a eucalyptus on a neighboring property can affect soil chemistry 20 to 30 meters away through falling leaf material and root extension, remove fallen leaf material before it accumulates, amend affected soil heavily with compost, and select eucalyptus-tolerant plants, including most bulbs, native grasses, and drought-tolerant Mediterranean species for areas within the chemical influence zone. Full stump grinding after removal is essential, as cut stumps resprout aggressively while the roots continue releasing allelopathic compounds. Plant 4, fennel. Fennel is a common culinary herb that millions of American gardeners grow in their vegetable beds every season, frequently without understanding why the plants immediately around it seem to underperform, despite receiving identical care. Feniculum vulgar is native to the Mediterranean, valued for its feathery foliage, yellow umbel flowers, and genuine culinary utility. The allelopathic mechanism involves furanocoumarins, phenolics, and volatile oils released through root exudates continuously throughout the growing season and through decomposing foliage and spent flower stems. Tomatoes show reduced growth and yield near fennel. Peppers, eggplant, and beans are similarly affected. Basil, cilantro, caraway, and dill are suppressed by proximity. Dill planted near fennel cross-pollinates and produces seed lacking the characteristic flavor of either parent. Even plants that tolerate fennel's immediate presence show measurably reduced essential oil production when grown alongside it. The practical approach is isolation rather than elimination. Fennel's umbel flowers attract parasitic wasps, hoverflies, and beneficial beetles that suppress pest populations across a wide area. Its deep taproot mines potassium and calcium from lower soil layers. The ecological contribution is real. The problem is placement, not presence. Grow fennel in a dedicated container or at the far edge of the garden with a clear physical gap between it and all productive planting areas. Plant 5, sunflowers. Sunflowers produce one of the most confusing allelopathic effects a home gardener can encounter because the plant appears maximally productive and healthy at precisely the moment it is most actively degrading the surrounding soil, and the damage is typically discovered in the season after the sunflowers are gone. Helianthus annus is native to North America, cultivated as a food crop for at least 3,000 years, and one of the most widely grown ornamentals in the world. The allelopathic compounds are concentrated in the leaves, stems, hulls, and roots, including water-soluble phenolic acids that leach into the soil through rainfall, decomposing plant material, and root exudates throughout the growing season. Concentration builds through the season and intensifies as plant material decomposes in autumn. Research documents sunflower allelopathy, suppressing germination and early growth of certain lettuces, some brassicas, some beans, and certain cover crop grasses. The effect is strongest directly beneath the root zone. Decomposing sunflower material left in place over winter concentrates compounds in the soil profile, which is why the most notable effects appear the following spring when new plantings fail in beds where sunflowers grew the previous season. Sunflower seed hulls drop beneath bird feeders, accumulate in significant quantities over a feeding season, and suppress grass and ground cover in the surrounding area, creating dead zones that most homeowners treat as a fungal or drainage problem without identifying the hulls as the cause. Remove spent sunflower material in autumn rather than leaving it in place. Rotate sunflowers to a new bed each season, relocate bird feeders periodically, and amend beds with heavy compost before spring planting in areas where sunflowers grew the previous year. Plant 6, Tree of Heaven. The Tree of Heaven has one of the most thoroughly documented records of ecological destruction of any invasive plant in North America, and the allelopathic compound it produces is among the most potent plant-produced growth inhibitors documented in the scientific literature. Ailanthus altissima was brought to the United States in 1784 and initially celebrated as an ornamental and street tree before its behavior in its new environment became clear. It now colonizes roadsides, forests, urban lots, and disturbed ground across virtually every state in the continental United States. The allelopathic compound is allanthone, a quasinoid produced in the roots, bark, and leaves that suppresses the germination and growth of a wide range of plant species, including agricultural crops, native wildflowers, and tree seedlings at very low soil concentrations. The tree also spreads through root sprouts emerging at significant distances from the parent, each releasing allelopathic compounds from its own root system, and a single mature female tree produces up to 300,000 seeds per year, capable of germinating on almost any surface in virtually any soil condition. Cutting the tree stimulates rather than kills it, with cut stumps producing multiple root sprouts that collectively cover more ground than the original tree. Effective management requires either professional herbicide application to cut stumps immediately following removal or a multi-year commitment to cutting all sprouts before they can photosynthesize, a process that takes 3 to 5 years of consistent management to exhaust the root system. For neighboring trees on adjacent properties, a physical root barrier buried to 60 centimeters along the property line prevents root intrusion into garden beds. Plant 7, English ivy. English ivy is one of the most widely sold ground covers in American gardens and one of the most consistently recommended solutions for shaded areas where little else will grow. The reason it solves that problem so completely is the same reason it creates a worse one in the process. Hetera helix is native to Europe and Western Asia, sold at virtually every garden center in the country, and available in quantities that reflect how consistently it is recommended for difficult spots. The allelopathic mechanism involves falcarinol and polyacetylene compounds released from roots and decomposing leaf litter that suppress the germination and establishment of competing plants. The dense layered canopy intercepts nearly all available light at the soil surface, combining physical exclusion with chemical exclusion in a way that eliminates virtually all competition within an established patch. In a contained bed, that competitive completeness is the feature. The problem arises when English ivy escapes, which it does reliably through rooting stems and, in the eastern United States, through bird-distributed seed from plants that reach their adult climbing form on tree trunks and structures. It is classified as invasive in 32 states. In woodland edges and forest areas where it escapes cultivation, it eliminates native ground flora, suppresses tree seedling establishment, and creates a monoculture ground layer that degrades habitat value for decades. The allelopathic compounds deposited in colonized soil persist in the organic layer and continue suppressing establishment even after the ivy itself is removed. The more sustainable solution is substitution. Wild ginger, Pennsylvania sedge, native Pachycandra procumbens, and various native ferns provide equivalent ground coverage in shaded, difficult conditions without allelopathic consequences or invasive spread. Plant 8, rhododendron and azalea. Rhododendrons and azaleas represent one of the top-selling ornamental categories in American horticulture, and the allelopathic effects of their leaf litter and root exudates represent one of the most consistently misunderstood sources of garden failure in beds that border these plants. The genus rhododendron contains over 1,000 species and hundreds of cultivated varieties available in American nurseries. The allelopathic compounds are concentrated in the leaf litter, which decomposes slowly due to high tannin and phenolic acid content. As that litter breaks down, it releases compounds that lower pH, suppress microbial activity, and inhibit germination and growth of many ornamental and edible plants even when pH adjustment alone is accounted for. The interaction with mycorrhizal fungi is particularly damaging. Rhododendrons selectively favor ericoid mycorrhizal fungi while suppressing the arbuscular and ectomycorrhizal fungi that most other garden plants depend on. A bed that has supported established rhododendrons for years may be depleted of the fungal communities neighboring plants need, which is why ornamentals planted adjacent to or beneath rhododendrons frequently show slow, weak growth that does not respond to standard fertilization. Maintain physical separation between rhododendron plantings and beds intended for other ornamentals or edibles. Remove fallen leaf litter rather than allowing it to accumulate, and when planting adjacent to established specimens, select acid-tolerant and ericoid-compatible plants including native woodland species, ferns, and other ericaceous plants that share the same soil chemistry preferences. Plant 9, spotted knapweed. Spotted knapweed releases a compound that does not just suppress neighboring plants, but actively triggers those plants to destroy themselves, one of the most targeted allelopathic mechanisms documented in any invasive species, and one of the primary reasons it has colonized 7 million acres across the western United States and Canada. Centaurea stoebi is native to Central and Eastern Europe, introduced to North America in the late 19th century, most likely as a contaminant in alfalfa seed shipments. The heaviest infestations are in Montana, Idaho, Wyoming, Colorado, and the Pacific Northwest, with the range expanding eastward and southward continuously. The allelopathic compound is catechin, released through roots at concentrations exceeding those documented in any other studied plant species. Catechin triggers a self-amplifying reactive oxygen cascade in the root cells of sensitive native grasses and wildflowers, causing those roots to chemically destroy themselves through oxidative stress. It also reduces the diversity and abundance of beneficial soil bacteria and mycorrhizal fungi in invaded soil, degrading the biology that native plants depend on for nutrient uptake. The result is a positive feedback loop. As native plants decline, decomposing roots release nutrients into the soil. Bare ground provides germination sites for knapweed seed, and degraded soil biology slows native plant recovery even when knapweed is removed. Early identification and removal before seed set, combined with reintroduction of native mycorrhizal fungi to affected soil and overseeding with competitive native grasses, represents the most effective non-herbicide management approach available. Plant 10. Black mustard. Black mustard is annual, fast-growing, and capable of transforming the chemistry and microbial ecology of a garden bed more rapidly than most perennial allelopathic plants because it completes its life cycle quickly and produces a dense biomass of chemically active material in a single season. Brassica nigra is native to the Mediterranean region and southwestern Asia and has naturalized across virtually every part of the United States, most abundantly in California, the Southwest, and the Pacific Coast, where it dominates disturbed habitats, roadsides, and post-fire landscapes. In parts of Southern California, it forms near monoculture stands covering thousands of acres in areas that historically supported native coastal sage scrub and chaparral. The allelopathic mechanism involves glucosinolates that decompose to isothiocyanates and volatile sulfur compounds when plant tissue is damaged or decomposes, suppressing native seed germination and inhibiting native seedling growth. The fire ecology connection in California is extensively documented. Black mustard produces large volumes of dry annual biomass that increases fuel load in native plant communities, leading to more frequent and intense fires than the native chaparral was historically adapted to. After each fire, black mustard germinates rapidly from its soil seed bank, covers the ground before native seedlings can establish, and uses its allelopathic advantage to suppress native recovery, resetting the ecosystem to its own advantage with each fire cycle. In garden settings, black mustard, completing its seed cycle in a bed, deposits glucosinolate-containing seed hulls and decomposing plant material that reduce the following season's germination in sensitive ornamentals and vegetables. Remove it before seed set, and remove the plant material from the bed entirely. Incorporating decomposing black mustard into the soil concentrates the allelopathic compounds precisely where they cause the most damage. The plants on this list share one characteristic that makes them difficult to manage as soil problems. They do their most significant chemical damage while appearing either completely healthy or completely absent, which means the damage is invisible until it manifests as poor growth and failed germination in the plants you actually wanted. The growing season spent fighting symptoms without identifying the cause is a growing season lost. Every one of the plants on this list has been winning that fight in one form or another for millions of years. Understanding what they're doing in your soil is the only way to stop losing it.